Okay, today we're going to take a look at adding and subtracting radical expressions. In order to be able to add or subtract radical expressions, the expressions must have the same index and the same radicand. So the index, once again, remember, is the number that appears here at the radical. In this case, it would be a 2. And the radicand is the thing underneath the radical. So here we have 7 square root of xy plus 3 square root of xy. In this case, we can add them because the indexes are the same and the radicands are the same. So what we end up with is 10, because 7 plus 3 is 10, square root of xy. So this would just be like if I said I have 7 bananas plus 3 bananas. I have 10 bananas. For example B, the indexes are the same, but the radicands are different. So these radicands, the radicals are not identical, so they cannot be combined. So take a moment, pause the video, and try these three quick checks. Remember that both the index and the radicand have to be the same in order to add or subtract. All right, let's take a look at another example. This time, before we can add or subtract, we're going to need to simplify each of these radicals. So simplify, remember, means that since this is a square root, we're going to try to find pairs and pull any of those pairs out that we can. So let's take a look at 3 square root of 20. And we're going to simplify this. Well, 20 we could split into 2 times 10. And then 10 gets split into 2 times 5. So we have a pair of 2's. So we can rewrite that 20 as 2 squared. And then we have a 5 left over times 5. All right, if we want to simplify this, we're going to pull out that 2. And we're going to multiply it by 3. So 3 times 2. And what's left under the radical is a 5. And if we further simplify, 3 times 2 is 6. So we get 6 radical 5. That's what this is. Let's take a look at the second one. So we've got the square root of 45. Okay, 45 we could split into 5 times 9. And then 9 we could split into 3 times 3. So we have a pair of 3's. Remember, we're looking for pairs because this is a square root. So we can simplify this to the square root of 3 squared times that leftover 5. All right, we're going to pull out anything in the parentheses again, remember. There's nothing out front, we just have a 1. So this becomes 3, and what's left over is the square root of 5. Okay, the third one, we've got 4 square root of 80. Okay, 80 we could split into 2 times 40. 40 into, let's say, 4 and 10. 4 I could split into 2 times 2. And 10 into 5 times 2. All right, let's see what we've got pairs of. Well, we've got one pair of 2's and another pair of 2's. We could rewrite 80 as 2 squared because we have 2 pairs of 2's, and then that squared. 2 times 2 is 4. 4 squared is 16, and we have a leftover 5. All right, so 2 times 2 we said is 4. So we're going to pull out a 4. 4 times 4 is 16. So we get 16, and we're left with the square root of 5. All right, so let's see if we can combine all these. So this 3 square root of 20, we rewrote as 6 square root of 5. So I want 6 square root of 5 minus square root of 45. Oh, well, that was 3 square root of 5. And plus, well, 4 square root of 80 ended up being 16 square root of 5. All right, let's take a look at these three radicals. They all have the same index. They're all the square root. They all have the same radicand of 5. So that means these are like terms. We can combine them. So 6 of these minus 3 of these. 6 minus 3 is 5. Or 6 minus 3 is 3. Sorry about that. And 3 plus 16 is 19. So we end up with 19 of these square root of 5s. So go ahead and try this first quick check on your own.